Hello again. This session is on EIGRP for IP version 4. It's only the basic setup. There's extra things we can add later on. But we're just going to set up a basic network, change a bandwidth so that we get some different information in there to have a look at and get a basic feel for it. It's an extension of RIP in a way, so hopefully you've done RIP before, because RIP is really quite easy to configure. EIGRP is equally as easy to configure, but there's some other differences. So still a distance vector routing protocol, but it's enhanced. It's got extra features to it and uses a range of different values for determining the metric. So we'll hop on. It's the basic network that we've used all the time. Well, when I say all the time, it's subnetted. So we've got 192.168.10.0 network down here, 192.168.10.64 network over there, 192.168.10.128 network up there, and these little 10 guys in there. So let's work our way through it, and we'll start on router 1 again. And good. Hopefully good. And I've just gone through previously just to do a show run, and everything's in there. So standard configuration. So all we're going to do is just go in, so configure terminal, and we're going to use EIGRP. And I'll just move this over just a tad because we're on router 1. So router EIGRP, and this is one difference between RIP. We have to put an autonomous system number in. Now every router that's running on this network has to have the same autonomous system number. So what we're saying is that router 1, router 2, router 3 are part of the same system, and they will be sharing information between them. Normally that number is given to you or by your ISP. So we're just using 50 at the moment, and there we have it. We're in EIGRP. So put a little question mark there. And first one, no auto summary. Turn that off because it auto summarizes as well. And pretty much very similar to what we've had before in RIP. So passive interface. Let's make that gigabit 00. So again, we don't want to send our updates out of that interface. We haven't added any network commands yet. We'll get to that. So just a couple of ones to start with. No auto summary, passive interface, the same stuff that we've used before. Now one thing we need in here is, well, we don't have to have it. It automatically is generated in EIGRP. It is good to put your own router ID in there, and it's in dot decimal notation like an IP4 address. But it's only the ID given to the router. So if we put one in there, that becomes the ID. If we don't, the ID would be a loopback address, the highest value loopback address, or the highest interface address. So if we weren't to put that here, then 192.168.10.1 will be the highest interface address on router 1, not 10.0.0.2 or 10.0.0.9. That's correct. So that's the highest address. So put a router ID in just to separate them. Not the same as OSPF. OSPF uses router ID for different functions. The only time we'd use it in EIGRP is for external routes coming in, and it does have an impact in that area. But let's chuck it in there now. Okay, so we've got three things. No auto summary, passive interfaces, whichever we don't want to send out into our LAN, and a router ID, so basic stuff. We then go for our network command, and here it's a wee bit different to RIP as well. It can be the same, and it can be different. So it does get a bit interesting. If I put this value in there, then it will, like RIP, advertise the 10.0.0 network and 10.0.0.8 networks. But normally what we want to do is actually put a wildcard mask in. Oops. Now that wildcard mask is the inverse of the subnet mask. So this network here, 10.0.0.0 30/30, its subnet mask is 255.255.255.252, and if you completely invert that, it'll come out as 0.0.0.3. So you're effectively saying 255 minus 255, 255 minus 255, 255 minus 255, 255 minus 252, and that's the result there. Now that's the pure added on value that we're putting in there. Should put the 8 network in there as well. I like the use of up arrows. And the other option for us is the other network. So let's do it correctly as well. So we'll play with other ones. So 192.168.10.64 is the network number for our LAN, and we want that advertised as well. And the wildcard as an inverse is 0.0.0.63. Actually, if you get it wrong, 61 comes up and it says a discontiguous mask. It's a bad combination, so when you generally get those errors, it's generally it's in your wildcard mask actually, or your subnet mask. So there it is, network 192.168.10.64. That's all running now. So EIGRP on this router, let's Control Z that, and show run, is actually running. There's our configuration. We've chucked in a router ID, passive interface. We did put in no auto summary, but it hasn't taken, so it's default. But I've just chucked it in from history of using automatic summarization across other things. And there's our 3 networks, all done nice and cleanly and neatly. So that's good. The autonomous system number has to be the same on every router. So let's pop up to router 2. Well, actually no, we'll go to router 3. Just change my mind halfway through there. And we'll do the same stuff. So configure terminal, router EIGRP, and our autonomous system number is 50, so we chuck that in. So passive interface, gigabit 00. And now we're going to do something a little bit different. We're going to chuck in a different command in our network option. Whoa, that is different, isn't it? So what I'm saying here, like we did with RIP, I want both these networks to be advertised, and all I'm using is the classful address. And what it's doing is it says, I will take every network that is connected to this, so that starts with 10, so the 10.0.0.4 and the 10.0.0.8, and I will advertise out of that interface and send off. And we've got a nice bit of information as well in there. So that information says dual, which is a diffusing update algorithm, which is what EIGRP uses, has found a neighbor change. So for IP EIGRP autonomous system 50, the neighbor's on 10.00.10, I think I got that wrong before, through our serial 000, and it's up. We've found a new adjacency. We've got a new neighbor. Now once we've got that neighbor and they've exchanged their databases effectively, not strictly true but close enough, then they don't ever have to keep updating. So with RIP every 30 seconds or 40 seconds, I forget, it will send an update of the whole routing table. So it's quite chatty across your network. With EIGRP, once we've formed an adjacency and it's worked out the best path to everything and it's all configured and sitting there happy, it will only send every so many seconds, and I'll come back to that, a little hello to say, are you still there? And that's all it does. Are you still there? Wait. Are you still there? Wait. So that little hello timer is just to say, are you still there? If I don't hear from you, there's a hold timer. Now the hello timer normally for fast Ethernet or faster, so this link down here is a gigabit network, those will be running every 5 seconds. For a serial interface, they'll be running every 60 seconds. So the hello timers do have a slight change depending on the interface that you're running on. So this one is 60 seconds for a serial link. A fast Ethernet or faster will be every 5 seconds, and this one popped up quite quickly. If we go back to router 1, you can see up here we had our adjacency giving us information there to our logging messages. So let's have a quick look in router 3 and have a look at some of the commands that we can play with. So if we show IP route, which is a handy one, IP route, then we've got dual has come through, and it's telling us that 10.0.0.0/30 network can be found down that path, so serial 000. This value is our administrative distance, so EIGRP's admin distance is 90, how trustworthy it is. And this is the metric, this is what it's worked out. EIGRP uses the slowest bandwidth on the link from router 3 to that destination. So in this case it'll use this bandwidth and this bandwidth up here. And it'll choose the slowest one. And a sum of delays. So there's a delay on this interface and there's a delay on that interface, and those two are summed together and they will go into this calculation, and you get out this value, which is called the feasible distance. So it's got a few things going on with it. The interesting one that I don't see here is 192.168.10.1 or 10.0 network does not appear here for some reason. So I should have a look and see why. 192.168.10.64. It looks okay to me. Do I have the wrong subnet mask, I wonder? Or wildcard mask, sorry, not subnet mask. I'm pretty sure it's correct. So we've got an error. Anyway, let's keep plodding on. So we'll go back into our EIGRP, and actually if we do show run, where were we? We've only added that network option at the moment. So let's add a new network command. So 192.168.10.0. Let's do it that way. Let's have a look at router 1 and see if it's changed anything. So if you show IP route on router 1, we do actually get dual coming in there, and dual, which is EIGRP, coming in there for this network. So this one's worked out quite happily. 192.168.10.64 found 26 bits on the subnet mask found through serial 000. So obviously I've got an error in my config somewhere. 63 is looking a bit dodgy, isn't it? Ah, there it is. Ha! It's 10.0 and I've put a 64 in there. Okay, let's pop into router 1 and just negate that command. So conft router EIGRP and the same autonomous system 50, and there it is. We'll say no to that network. We do not want to propagate that, even though it's not going to make any difference to our system, because no network with 64 is actually in there. It's good to clean up. So let's go back to router 3 and show IP route. And there it is. So nice little problem there, nice little error, bit of troubleshooting. Okay, so far so good. So we've seen a few different commands. So show run, and we'll pop right down. So in this case we've only put in the classful network addresses, and they've worked out quite fine. Same autonomous system, we've got passive interface in there. We'll go into router 2 just to show you another option. Now this isn't running at the moment, so conf t router EIGRP, and I did leave out the router ID for router 3, so I'll have to go back and do that. So EIGRP router ID, and in this case dot decimal notation, we'll put that in there, and we'll put our network commands in. Now the absolute interfaces, so 192.168.10.129 is an option for us. So 192.168.10.129, whoops, one extra zero, and we want to copy or say we're going to use exactly that IP address. So no neighbors yet, because I want to just check the IP addresses of these two interfaces here. So what I'll do is go and do show IP interface brief. Do show IP interface brief. So 10.0.0.1 and 10.0.0.6. So give me 10.0.0.1 is the absolute IP address that I want to put into this network. Boop. And we found a neighbor. Let's put in 10.0.0.6 and hit enter there, and we've got another neighbor. So in this case up here, the network is not actually the network number. We actually put in the IP address and say I want to match this one exactly, but it has come up with a whole bunch of things. So let's show IP route, and we've got the 0 network, the 64 network coming in via dual, and again, like RIP, we have the 10.0.0.8 network as two paths, two equal cost paths. So the cost there and the cost there, exactly the same values. So it will load balance again. So that's what we want to see actually. That's pretty close to being complete. Let's go off and look at router 3. Show IP route. Now it's come in and given us that network number there. Again, we've got those network numbers there. Now this is from router 2. So if you remember from router 2, show run, the actual commands is the why is that jumping around? The absolute IP address. The absolute IP address. But on router 3, we've acquired the network numbers. Interesting. On router 3, show run, we put in to our EIGRP the classful addresses that have been subnetted. And again on router 2, show IP route, we've actually acquired the correct subnet mask for all our networks. Back on router 1, we show run, we actually did it correctly. Well, did incorrectly to start. We actually put in the wildcard mask, which is the inverse of the subnet mask, for these absolute networks. We actually said there's 30 bits in that subnet mask, there's 30 bits in that subnet mask, there's 26 bits in that subnet mask. But the same outcome across the whole network eventuated. Now, let me just tidy up my little mess there. So my router ID, and by changing that, we've actually got everything rejigged. So it pulled down EIGRP, brought it back up, and formed adjacencies again. Okay, so that's it in a nutshell actually. But there's a few other bits and pieces that are nice to look at while we're in there. So we've actually configured EIGRP almost entirely. One thing we need to do on router 2, which I should do now, actually I'll just do that now. We need to get our internet across to these guys. Because if I show IP route, I don't have a gateway of last resort set. So I need to put that into the system. So here's my gateway out of my autonomous system, is router 2 out to the internet up there. So let's pop into that one and do that. Now router 2 does have a gateway of last resort, it does have a static address. Let's just have a quick look at that. So if we show running config and spacebar all the way down, there's our IP route 000, and that's the next hop address out there on the internet, so that's our ISP's address there. So what we want to do is different to OSPF and different to RIP. So we're going to config mode and we're going to router EIGRP and we're going to our autonomous system again. Now once we're in here, if we put a question mark there, we don't have default information originate, which is what OSPF and RIP use to take the static default route on this router and put it into RIP or OSPF. What we do have though is redistribute. So what redistribute does is take data from another routing table and put it into EIGRP. So we can actually redistribute. If we were running on this route, if we were running OSPF here as well, or RIP, we can take that routing table from that OSPF has created just for itself and chuck it into EIGRP and vice versa. So in our case, we just want to redistribute static, and we'll put a question mark in there. That's all we need to do as far as CCNA is concerned. However, it's nice to know that we can modify the metrics, and this gets a bit messy. So let's just hit enter there for now, and we'll go back in there and just have a look at our metrics, because it does get a bit wild. The bandwidth metric, so this is starting to look at the K values that EIGRP uses to determine the cost of getting somewhere. So if you've got multiple exit interfaces or paths out of your network to different ISPs, then you can manipulate and modify the metric and the calculation that the EIGRP uses for the correct one. So in this, the bandwidth, so 128 in kilobits per second. Next one is the delay, so all these values can be put in, so we won't go there. Let's just check out and see if everything has worked. So let's show IP route now, and we now have a gateway of last resort. Our command is done differently down the bottom here. It's coming in via dual. It's our candidate default route with the asterisk there, and it's an external route. It's saying this is the network that we need to get access to. Now there's our metric. We didn't change that. There it is. It's still got our path. One thing we'll notice is the administrative distance has changed. So internally, EIGRP has a trustworthiness of 90, but as soon as we get an external or redistributor route into EIGRP, it bumps it up to 170. So all done. Let's just have a couple of show commands there. So If we show IP EIGRP, we have a few different options. We can get a topology, and we can look at our AS number, or we can do the whole box and dice because we've only got one AS number in there. And this shows us all our different paths. And this gets a bit chunky. So we've got successors, which is the actual next best path. Its feasible distance is 2425856, which is the cost, the metric that we're using, and that's the same value that we're using there. And it is found that from another router whose advertised distance is this value here. So there's quite a lot in this. So I recommend you go and have a look at it. I won't spend too much time in here because I'm getting a bit of background noise, which is getting incredibly annoying. But I've got neighbors, so we can find out what our neighbors are, how long they've been up. There's a hold time, uptime, a few bits of information for us, but just for that process ID there. So we might call it quits there. Basic setup for EIGRP. Most of what we need is in there. We'll go through other stuff a bit later on another video. Thank you for that. Cheers.